Well, hello friends. Today we are going to work on the profile viewer and I'll show you what I have in mind. So first let's just capture a quick profile here of system monitor, for example, just a little resize action. And then we'll look at the profile for that. So here, let's just select some area and we can see what's going on in that time range. Now, the only available information we have at the moment is the number of samples at every stack frame, and then at each frame sort of shows the accumulated number of samples within that subtree. So you have to actually go down into the leaf nodes if you want to see how much time is actually spent in an individual function. So today I would like to add it so that we can see not just the sort of cumulative number of samples within a subtree, but also the number of samples at that exact location as well. So we would see here, for example, like how many samples were captured while we were in this function, not just within any of its descendants. So the self column, basically, if you're familiar with profiler terms. And then I would also like to have percentages, because right now it only shows sample counts. And if you're working with samples and the total number of samples is not like 1,000 or 10,000 or something like that, then you have to constantly do division in your head to figure out relative sample counts, and that's just silly, right? Because we could just compute percentages and show you that. So, but I think it's nice to have both. So let's add a mode for percentages, and then yeah, if I can get those two things done, I will be very happy. So we'll start with the self number. So basically showing the number of samples collected at a specific stack frame when it was a leaf, not just when one of its descendants was active. So we'll have to go in the profile model, maybe. So the profile model is the data model that we see on screen when ProfileViewer is running. So we can see here are the columns. There's the sample count and the stack frame column. And the data retrieval is very simple. For the display role, the sample count just shows the event count, and the stack frame column just shows the symbol. So I think what we're going to do is we're going to add a new column here. We'll call it like self count, something like that. And let's just add that everywhere. And event count, maybe with self, call it self count. And just like this one, he will also be, we can do it this way actually. It will be right aligned, because it always looks better if you have numeric things right aligned, especially with a fixed width font. It just looks really nice. So self, and we don't even have to say, we can just, well, I was thinking like we could switch this one between percentage and hashtag, but we'll get to that. Let's just make sure that we have it everywhere. Maybe that was everything. Okay, so now we got to deal with counting these things. So the event count, I guess we're going to have to look up how we compute that, because I don't quite remember. I'm just going to add this counter here. So the way that we represent the profile in memory, if you were not here when I was writing the profile viewer thingy, basically we take the profile data. I'll show you what it looks like. If we just generate a profile, bin ID, and then we can JSON print proc profile, and this is what the profile data looks like. So you have a PID and an executable path, and then you have a series of profiling events, and an event is a thread ID, a timestamp, a type of event, and then stack. So the stack here is basically what we end up seeing in the profile viewer. It's the address of each function that was calling another function and so on. And this is what we use to build the tree. And so we take all of this and then we turn this stack here into a tree representation where we find sort of common paths, and then we accumulate counts every time that there's a common path, and then we build a tree from that. You probably understand what I mean if you look at what comes out of this. So this is the input, and the output looks like this, right? So this is the stack right here. So this is the first stack frame, or the root stack frame, and then it goes da 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 da. And so start would be down here, and then this one would be main, and so on. It goes all the way up to something in the kernel that we can't see because we are not root. Of course, if we are root, then we can see it. So just out of curiosity, what is it calling? It's calling the read syscall. Makes sense? Anyway, so what we are interested in, previously we were accumulating this event count, which is the cumulative count of everything within a subtree. Now we want to compute the self count, which will be the number of samples where a specific node is the leaf node is a leaf node. Or is the innermost stack frame, if you will. So let's see how event count is handled. So there's increment event count. I think we can probably do something like this. And then we'll figure out who uses that. It's this guy right here. Okay, so when we rebuild the tree, so the profile viewer sort of rebuilds the tree whenever you change the settings, because you can invert the tree and then you get it sort of flipped upside down where the innermost become the outermost stack frames. And so we're always rebuilding the tree based on your settings, and here is what we're doing for the stack frames. So we walk them for each frame. Wait, how does that work? Oh, it's right here. I was wondering, where is that function for each frame? Why does it look so weird? Shouldn't it be like that? Yeah, I never know what to expect from the auto indenter. Also, I think this is maybe a C++ 20 thing that QCreator does not like, but since GCC accepts it, we're just gonna keep using it because it's really nice to do templated lambdas. Okay, so we are walking the stack frames in an individual profile event, and what we do is for each stack frame we find or create a root. If we don't have a node, what is node? Node is here. Okay. Right. Okay, so this is just tree building basically. So we look for a root if we don't have a node, but for every other step of the iteration we'll be on this path of find or create child within node. So we're always like adding a child to something, and if we don't find a child, we create a child. So here we increment the event count of node every time. But what we want to do is we want to increment the self count, but only if this is the leaf or the innermost stack frame. So in order to know that, we have to know if there are any more frames following this one, so we can't do like for each frame like this. Or wait, well, actually we can. We just have to tell it. So we'll include in the callback here whether or not this is the last frame. So we'll pass that as a Boolean, and then we'll take that here. Bool is last frame, or even is innermost frame. Innermost frame, node, increment self count. I think maybe that would be pretty good. Let's see how this turns out, because I'm not sure I'm doing this right. Wait, what's wrong with this? I is a SIT. Oh, shit, right. Because we're iterating backwards, so I guess I'll have to cast him to a size t. And there we go. Backwards iteration is not where I want it to be at the moment with our containers in Serenity. I would like to have better abstractions for iterating backwards, because iterating forward is really simple, right? You just use range 4 or something like that, but iterating backwards, I know there are solutions. We just need to choose one and then come up with some nice ways to do that with our classes. Anyway, so let's get some samples. And let's open this guy up. So this definitely looks stupid, and also not right. And why does it look this way, I wonder? I guess I never tried having more than one column before the tree before, but anyway, maybe we can still see something. Yeah, okay, so I was hoping to see some interesting self numbers. So we got them right here. So we have a lot of, supposedly a lot of things that, a lot of stacks in window event itself. So if that's true, we should be able to turn it around and we should see them like this. Because when you invert the tree, then basically every root, then you're going backwards. So the innermost stack frame becomes the root, and then of course the self and the total count, the cumulative count, subtree count, whatever we call that. What should we call that? Total? I don't know. Maybe total. Anyway, it becomes the same number as the samples and self become the same, because the innermost is the innermost. So I guess it does turn out that we are spending a lot of time in GUI window event. That's kind of surprising. GUI, what are we even doing in there? I just want to go and take a look at it. What would we be doing in this code? I don't know. I mean, I was resizing a lot, so we would be in like paint or resize. It's like, you know, doing some rect stuff. I guess we are throwing away a bitmap here. I guess that might end up taking some time, but it is weird. Anyways, you can't always argue, you can't really argue with the profiler, so I guess we are spending time in there. Or I shouldn't imply that the profiler is perfect, because it certainly has some bugs, and it's not perfect. So maybe it is fair to argue with your own profiler that you are currently developing. Anyway, we got to figure out what's up with this goofy ass number showing up under the thing there. So if we go to the profile model, what is going on? Stack frame, blah, 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 blah. So I guess we're gonna have to look at the tree view to figure out what this is going on. Damn, it's been so long since I looked at this. But it's a good thing. A good thing to get a refresher. So tree view, what do you do, tree view? Shit, let's just look at the paint event. Okay. So the paint event will traverse the model in paint order, and then it will give us a model index and a rectangle and the rect for the little toggle. The toggle rect is the little plus thingy that you can click to toggle. I'll bring that up. Oh. And show you. So this is the toggle rect right here, this little plus minus guy. And the rect here, when we traverse in paint order, I think that's just I actually am not quite sure what that is anymore. I forget. Let's see what we pass to it. Traverse, and then we recurse. And where's the callback? Right here. Passing the rect, and the rect is oh, it's the column rect. Okay, so it's like from here to here, 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 presumably. Or maybe, actually, if you look at the width of it, you can see that it's the icon size and all the spacing and the width of the text. So maybe it stops here, actually. Anyway, why are you doing this? So I guess the toggle rect is too far to the left, right? So if row count at index is greater than 0, so if this is not, wait, what is that? Oh, row count at index. So that means if you have children. If you don't have children, then we don't do a toggle rect. Okay, that's what that means. So this guy here has no children, so he has, at that index there's row count 0. That's how the model works. So, wow, my fan is so loud. I guess it's busy doing stuff. Anyway, what did I want to do with this? Figure out why the toggle rect is too far to the left, right? So the tree column X offset, I feel that this is a highly suspicious thing, because this should already give us a boost so that we start here. Why isn't the tree column X offset here? Because then we're just adding stuff after that. And I guess finally subtracting 4 from something, from this minus 4. Gosh, this, I find it hard to read things when they're not like parenthesized. Like, this is easier. Why did I even do it this way? This is clearly a lot easier to read when it's like this. Okay, but why is the tree column offset like this? So in the X offset, So tree column x offset, what are we doing with that? We iterate through this thing and then we compute whether the column is hidden. If it's not hidden, then we add the width of, So we look at all the columns before. So we look at this column and then this column. And I guess we are, maybe there is a padding issue here, like, because what we're doing is essentially saying that the tree column x offset is the sum of the column widths of all the columns to the left of the column that has a tree in it. Because in a tree view, you can have many columns, but you can only have one column with a tree in it. That's sort of how the tree view works. That's why we're able to have these additional columns here, but there's only the one tree. I couldn't have a second tree column because then things would not make any sense, right? The tree view, by the way, is such a good example of this GUI widget that you take for granted, but then you sit down and you try to implement one, and you realize that there's a lot of finesse to these things. It's really, really good exercise, I think. At least it was for me to implement this thing. So I think this is going to be a padding issue, that we're just summing these widths together and we're not taking padding into account. So column width, and do we have such a thing as column padding or horizontal padding? Yeah, right. So the horizontal padding is what exactly? Is 5. I'm not sure if I see that 5. I think it's essentially like on the left and the right here, so distributed between those. But let's see if we can see it actually being added somewhere in the math. So the painting code, this is drawing these lines here, so that we don't care about that right now. But where's the other horizontal padding stuff? Select horizontal padding plus x offset. Oh man, okay, I'm gonna have to cheese this, and I'm gonna cheese it and look in the GIMP. Open this one. Okay, so how far is it from the start? So it's like 1, 2, 3, 4, 5, and I'm probably wrong about where the start is. So 1, 2, 3, 4, 5. That would make sense. So that would be the horizontal padding. And then as you can see, there's like no padding on the right. So we only pad on the left, I guess. And then we just, yeah, okay. So we only pad on the left. Phew. Then, in order to make this work, we'll just say tree column x offset plus equals horizontal padding. But this is going to make things look weird for the situation where we have only one column, I guess. Well, we can deal with that. Wait, what? Oh, dude, I didn't realize that this thing was cutting into the icon. Look at that. We're drawing the icon first, and then this guy takes over. That's slightly unaesthetic, isn't it? I never realized. This bothers me on a level. Do not like Because it's kind of inconsistent, right? Because when we have a line pointing to the right, then there's all this space here, and then when we have a line, a vertical line, then it goes right into the icon. Yeah, we could definitely do better with that. Okay, anyway, I'm gonna stop freaking out about that detail right now, and we'll get a move on here. No, I want to run. Profile. Okay, so I feel like now the text at least is in a slightly better place, but other things did not come along. The heck? Why did it end up like this? What? Because the Okay, this type of stuff is so annoying. So we're adding 5 per one of these, and then this one does not include the padding, right? Or does it? No, it's just the width, and we get the width from the model. Okay. Okay. And now our well, we're still not far enough to the side. Do we compute this elsewhere as well? Column width. X offset plus equals column width plus horizontal padding times 2. Okay, so maybe we should times 2 that sucker, even though I didn't think we should. And wait a minute. Here's this code. Where was I changing it? Oh, I was in Paint Event. Oh, this is duplicated in 2 places. Well, that's stupid. Let's put this in a helper function. That makes sense that everything would get so weird, because the traversal used one X offset, and then the paint used a different one. So let's just say tree column X offset, right? Tree column X offset. Let's make a function that computes this, because this is annoying. And we'll just put it here. Tree view, tree column X offset. And the tree column is and tree column is a model tree column. And we'll just make a helper. Okay. Okay, and this will work like this, and then we'll return the offset. There we go. And is column hidden. Tree column X offset. Okay, are we using this right? Tree column X offset, and we're calling it from Paint Event and from Traverse and Paint Order. And here was just that little parenthesization thingy. Okay, you don't like me now because I have an unused variable. My sincere apologies. By the way, I just recently turned on these colors in my GCC error messages. I did not realize that they had been off forever. And I started getting pretty good at spotting the problem in this old style uncolorized output. And when I put it back on, I realized that's just such a silly skill to develop. Like, it's so much better with the colors. Anyway, okay, prop profile, and now it's looking downright reasonable. Okay, so the problem was that we were not taking the horizontal padding into account. Very nice. And we got the self number too, so like it. Let's just see here that this tree view still looks all right. Yeah. And I guess we have one more tree view that we can test, so let's go to the help app and see that this tree view looks good too. Yes, in fact, it looks very good. This app is so beautiful that I don't even know what to say. Let's see what we have. Let's do the libGUI change. So, fix broken tree view rendering with more. Fix broken tree view rendering with more than two columns, really, because then you start to accumulate too much error because of the missing padding. The computation of X tree column X offset was not taking the horizontal padding between taking padding into account. This patch fixes that and collects the logic in a helper instead. Helper, yeah. And now we also have the self thingy, so we can commit that. ProfileViewer. Show self counts in profiles. The self count sample count is sample count is the number of samples that had this specific frame as its innermost stack frame. Leaf nodes. Profile tree. Yes. So if you're not familiar with profiling, by the way, I guess I should talk more about this. Then the reason that the self counts are so useful is because let's just and let's see, PV profile. The reason that they are so useful is because it allows you to browse a profile like this in the regular bottom up or regular like root at the root structure, and you can still spot these things that are individually heavy. So, oh, my throat. You can see here that GUI window event is heavy, has a heavy subtree inside of it, but it also is heavy itself. And before, when we didn't have the self number, then it was very hard to see that, because you would look at this and you would assume like, okay, well, I guess that time is spent in the descendants of GUI window event in the call tree. But as we can see here, a large part of it is also in GUI window event itself. So profiling utility kit is growing here, or the toolkit. Now let's do percentages. So how do we do that? Let me just drink. Because my throat is giving up on me a little bit, but we're going to keep going a while longer. So first thing is we'll add a way to toggle it. So we already have invert tree, and I think we'll add a percentage versus counts. Percentages action, percent action, yeah. Show percentages, and maybe P as in percentage, Control P. Maybe, I don't know. Part of me feels like Control P should be reserved for print, but at the same time, I have no interest in printing, so I think maybe we can clobber that shortcut. Set show percentages, and this one will set check to false on startup. Yeah. Okay. So how do we do this? I guess we can have it on the profile. Yeah, that's okay. No, we don't need that. Okay, and show percentages. Okay, and I guess we can call it show percentages because we are not savages. And we don't have to rebuild the tree. We just have to tell the model to go into percentages mode instead. So how do we get to the model? Model, okay. Set show percentages, and then we'll let the model deal with this. Presumably we always have a model. Yeah, we do. Okay. So this is going to be super easy. Barely an inconvenience, I hope. Wait, set show percentages. Or actually, he can just ask us. We don't need it to be a state of his. We can just say model update. And here, this did update will just cause it to re-render. And then we can do something differently based on percentage of stuff here. So like M profile. Yeah, now we're going to need a getter for this actually. Dang it, I thought I didn't need the getter. Showing percentages. Showing. This is awkward. Show percentage. Normally I would like to name it like this, but the issue is that it sounds kind of imperative, right? It sounds like show the percentages right now. So I kind of go with like is showing, or shows percentages. Sometimes should show percentages. Maybe I'll try this on this time. try on this slightly imperative sounding one. See if I feel bad about myself when using it. So if profile show percentages, then percent samples. We'll do the same here, percent self or count self. All right. And then here we gotta do a little bit of computation. So in the sample count, if m profile show percentages, return node event count divided by node m profile events size, maybe. And we'll do a little bit of this, a little bit of that, and a little bit of that. All right. And maybe we'll do the same for the self count. Okay, so maybe that's good. Let's try it out. Zoom. All right, so can we switch? Poof. Oh, it updated the model so much. So, right, yeah, now we can see samples, 100%. This makes sense because everything is below this thing here, right? Everything is within this subtree, and then you can see that 97% of all frames are within the main subtree, and then we got a little bit of static initialization here. And then 68% of stack frames are within application exec, but then here we have some construction that happens on startup. So this is actually like a good time to show off this other feature where we can like select what we want to see, because if we select only this, then we get rid of everything that was during startup, right? Because now we've selected stuff that happened after startup. And if I'm only interested in startup, I could do something like this instead. And then we see mostly stuff that's like constructing the window and the widget hierarchy and so on. So this what did I call it? Timeline widget, I think. Very handy. Anyway. Oh, this self, it should not be based on the total number of events in the profile, but rather based on the total number of events in the current selection of the timeline. So it's a good thing I started messing with that because wait, hold on. Yeah, it should still say 100 here if I do this, because 100% of the samples in this selection are below start. I feel like that would be a better representation, so let's fix that up. How do we get the, how do we know how many things are selected? The timeline widget, profile timeline widget, when you mouse move, then we call set timestamp filter range on the profile. And that causes us to rebuild the tree. I guess we could say we can have a counter for this. So when we do a tree build, then we'll just say like node count and or event count maybe, like filtered event count. And we'll just add these filtered event count. Here we'll say like m filtered event count. I think that will be useful, and then we'll just put that next to this guy, and then we can ask for that. So like filtered So when we're computing the percentage, we can just ask for the filtered event count, and that will give us the number of things that were currently selected on the timeline. Let's profile something else, like profile Minesweeper. All right, let's play a game. Boom, 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 boom. Oh, I died. Terrible. Okay. So now if I select here, then, oh wait, let's switch to percentages. Yeah, so you always see 100% there. I think that makes a lot of sense. This profile is terribly uninteresting. Let's do something much more hardcore, like this guy right here. Okay, well, maybe it's not super hardcore, but at least it's something. So select this. Yeah, it's always 100%. So this should be, like, these should basically be pretty identical because it's just doing the same thing every loop. And it's really cool now that you can see that this guy has 50% of the samples in him, in his subtree, but only 56% in himself, and then you got 1% in the children here. Cool. So I wish that the tree did not close when we switch the mode like that. That's a bit annoying. Maybe we could hack it. So it's kind of an issue that we always collapse the tree view when the model updates. That's because we don't have very smart update management in the model view classes at the moment. It's definitely something that needs to be improved, but maybe we can do a little bit of a hack this time and not do a full update, but only like do a repaint. It's a little bit gross, but I think maybe we can live with it because it will be very ergonomic. Set show percentages. So no update like that. Instead, we'll just do set show percentages. We'll just do nothing here. Ooh. And in prof main, we'll do like tree view, filthy update. And this should allow us to switch between percentages and counts without losing our place in the tree. Of course, we always have to profile something, so we will profile. Oh, forgot to put that in quotes. Look at that cool message of the day. Very cool. And oh, what a terrible profile. Jeez. Okay. I'll get something else. Snake. Come on, eat the cauliflower. Alright, eat the paprika. The other paprika. And the other paprika. Alright, that's enough. Where's the thing I want? Here. All right, we got some samples. Fine. So, percent, look at that. Counts. Boom, 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 boom. That's very, very cool. I wish we could see the kernel things as well, because now I'm kind of curious what Snake is doing. Seems like most of the interesting stuff happens on startup, and then when you're running the game, it's like nothing. And on startup, it's loading the font database. Look at that. And let's see that it works in the menu as well. Share percentages. Boom. What happens if we invert with percentages? It's a very strange looking tree. I guess that makes sense. The inverted is a little bit hard to intuit about the inverted tree, but it's a very useful tool for finding hotspots. Anyway, I'm going to stop playing around with this because I have infinity curiosity about these type of things. So let's just commit what we've made. Add a mode that shows percentages instead of sample counts. Percentages are often much easier for the human brain to understand. Can sometimes be. No, percentages often easier to work with. And now we can show them. I just want to have space for one of those. How do I fit it? Now we can show percentages. Why is this so hard today? Percentages can sometimes it's much nicer to work with percentages than raw sample counts when browsing through a profile. Oh, wow, now everyone knows how much effort that took. Okay, so I think we're going to be done here for today. So this will be the end of the video. If you made it this far, then I thank you for watching and for hanging out with me while I work on the profiler. And let's load some big page here and see what it's doing. Alright, that's enough of that. And yeah, I hope you saw something interesting here, and that you also go and learn about profiling if it's something that you're not already into, because everybody should learn about profiling. It's an amazing thing. Anyway, thanks for hanging out. This is too much fun. I have to stop profiling things because I'm just going to get stuck here. I'll see you guys next time. Bye.